Hey there, so on your Tuesday planner, we have, today's 5/5, that's kind of funny, 5/5/20. We have science to read and a foldable to do. The foldable I'm going to do in a different video because it's going to take me a minute to get that all straightened out. This should be stapled out by itself, states of matter there. Let's just look at your section. So F4 in your trusty dusty red panda science textbook that you're going to return pretty soon. Properties of matter. This should be a review. Our words are matter, property, volume, and mass. Matter is anything that takes up space and has mass. You are made of matter. This book and your pencil is made up of matter, as is this little toucan parrot and the crayons on the paper. Every object that we can name is made up of matter. The world is full of many kinds of matter. How do we tell them all apart? Well, matter can be described by using its properties. Or a property is a characteristic of matter that you can observe. What are you talking about, Miss C? Well, observe means to use your eyes. Okay, so we're going to look at some items and determine what they look like. You can also observe by using your smell, and you can determine weight. You can also determine if something is soft or hard, and you can look at it and determine if it's shiny or dull. So let's talk about this. We observe color, size, and shape with our sense of sight. We can also observe texture and luster. So texture is when something is smooth or rough. Luster is shiny, like this dime, or dull, like this desk. It's not shiny. Okay, so texture is how an object feels when you touch it. Luster is how an object shines in a light. This book has kind of got a good luster going today. Also, that's a super lamp, so that might be part of it. So check out the dime here in the bottom, this chart. A dime, its color is silver. Its shape is a circle. It is hard and bumpy in texture. Flexibility, does it bend or does it not? Now, it doesn't talk about that word up here, but it does down here. Flexibility does not bend, kind of like Miss Christian, I cannot bend. Luster, it's shiny. The other option is dull. Diameter is how wide it is, 1.9 millimeters, which we've talked about in math. And its weight is 2 grams, so it weighs about the weight of 2 paper clips. It would be equivalent. Okay, that's just looking at something. Volume and mass. Some objects take up more space than others. An object that takes up more space has a greater volume. Kind of like when we turn up the volume on the radio. It fills up more of the room. It gets louder, has a greater use of the space. So the same thing is for large objects. Volume is how much space an object takes up. The beach ball has a greater volume than the bowling ball. The bowling ball has a greater volume than the little rubber ball. So we're just talking about size when we discuss volume. Another way to describe objects is by their mass. Now, this is going to change. The order what here was largest, middle, smallest. Now, this is going to change for mass. Mass is how much matter is in an object. An object with a large mass feels heavy, like the bowling ball. An object with a small mass feels light, like the beach ball. The bowling ball has more mass than the beach ball. And in fact, this little rubber ball has more mass than the beach ball. So earlier by volume it was 1, 2, 3. But now by mass it is 1, 2, 3. So volume is taking up space where mass is weight. It's really the pressure of gravity that we measure. How do we measure mass and volume? Larger objects do not always have more mass than smaller ones. The bowling ball is smaller than the beach ball. However, the bowling ball has a greater mass. How? Well, what is the bowling ball made up of? You know this. We've talked about this before this year. And what is the beach ball made up of? Well, this one is clay and some other plastics and polymers. And then this one is just plastic sheeting. What's the difference between the two? Well, it's what's inside. So the bowling ball, is a solid. Its particles are packed together rather tightly. So it doesn't have much air in there. Whereas the beach ball is full of air. This thing's going to float. This one's going to sink. So the more matter that's inside, the heavier it will be. The more mass it will have. Now the beach ball, I wish they both didn't start with a B. The beach ball still has more volume because it's larger, but the bowling ball has more mass. Matter is made of very tiny particles. In some objects, the particles are close together. You're old enough, I'm going to tell you the word is atoms, A-T-O-M-S. It's not particles, it's atoms. In other objects, they are farther apart like a gas. Particles inside the bowling ball are packed together tight, while those in the beach ball are all over the place and loose. The bowling ball is made up of more atoms than the beach ball, so it has more mass. Matter with tightly packed particles is called dense matter. So the word dense is like a forest that you can't quite see through, whereas loosely packed, you can see through those trees if it were a forest. Matter that is dense usually sinks. Matter that is less dense will float. All right, this is where science and math kind of go together. One unit to measure mass, is called the gram. 1 gram is the mass of about 2 small paper clips. A nickel has a mass of about 5 grams. Well, that's lucky. A nickel's worth 5 cents. You can use the letter G to stand for the word gram. More massive objects would be measured in kilograms. 1 kilogram equals 1,000 grams. This prefix here, kilo, K-I-L-O, that word, or that prefix, those 4 little letters mean 1,000. So kilometer, kilogram, they are 1,000 something. So 1,000 grams. An 8-year-old has a mass of about 30 kilograms, so 30,000 grams. You can use the letters kg to stand for this one. 1 unit to measure volume is the liter. You can use the letter capital L to stand for a liter, and this is a 2 liter of juice. We have discussed this in math. And we have discussed this earlier in the year when we went to space. How are mass and weight related? The more mass an object has, the more it weighs. How are mass and weight different? Okay, so weight is the pressure of gravity that your body puts on the surface that's being measured, that you're standing on. So when you stand on a scale on Earth, it measures how much gravity you are pushing onto the Earth. If you were to stand on that same scale, same person, on the moon, now you're going to have a spacesuit, which is heavy, so you'd have to subtract the weight of the spacesuit itself. And you were to stand on the moon, your weight will be different because the gravity on each planet is different. If you were to visit the moon, your mass would stay the same. So the inside of your body is going to be the same as long as you measured within the same time frame. Now, if you waited 2 years, your body's going to be different because you're constantly growing. The matter inside you would not change, however, you would weigh much less. This is because the weight of an object depends on the pull of gravity. Gravity is the force pulling 2 objects together. Your weight is the pull of gravity between you and Earth. The pull of gravity on the moon is weaker than on Earth because it's smaller than Earth. So here we would weigh less. Weight is an example of a force. Remember, a push and a pull. Okay, an open and a close. They are opposite forces. Forces can be measured in units called newtons. We talked about that when we talked about the apple. If your mass is 25 kilograms, then your weight on Earth is 245 newtons. So there's some special formula that calculates that. You obviously don't have to know that. It's just letting you become familiar with the term newtons, which is named after Sir Isaac Newton, a famous scientist. Why is this important? Matter takes up space and has mass. That's why two objects cannot be in the same place at the same time. You can be close to one another, but you cannot be physically in the same spot at the same time. You can describe matter by naming its properties, like you might describe your new sneakers to a friend, especially if maybe they couldn't see them, like right now. You could describe them to them over the phone. Knowing an object's properties is important when you need to find a lost item. Oh my goodness, I have told Draker that before. How are you going to tell a policeman what I look like? I mean, am I sort of tall? Am I sort of brown hair? You got to know what your parents look like. I would really love it if you also knew your address and your home phone number. Those are important life skills. So how are you going to tell somebody where you live? Or what your parents look like? Alright, I'm going to tackle this foldable in my next video. I got to go get my supplies. I think you're going to need some, like, scissors. Scissors. What's wrong with these scissors? Pencil. And some glue. I wanted to do a little bit more of this for you, but I figured it might make for an interesting video. So I'm going to hit stop, and then I'll come back to you for part 2. Love ya.